Alright, Common Core Algebra 2, we are here for our last unit, or last section, I should say, in Chapter 2. This is going to be Section 8. It's going to be all about solving linear inequalities and in two variables. So we're going to have a y and an x. Basically what we're going to do is graph a line the way we have graphed a line in the past, like in 2.3, 2.2, and then we're going to shade one side or the other, kind of like we did from Chapter 1 when we graphed a single variable inequality and then shaded one side of the line whether it was greater than or less than, or we could say greater than or equal to, less than or equal to. Okay, so those are our two objectives for today. Now before we do that, we want to talk about what is the solution to a linear inequality. And it's any point that makes a linear inequality true. Now when we did a line, the line was a representation of all the solutions. So if we graph a line, we have an x and a y. And those two together make a solution to that graph, to that equation. A linear inequality is going to have a lot more points of solution because it's not just the points that are on the line. And in fact, the line may be no part of the solution depending on how we graph it. So we would ask, is negative 1, 2 a solution to the equation? Well, I'm going to tell you right now, this point is not on the line that we would actually graph if we did y equals negative 2x plus 5. But we're going to see if it's a solution. So we do that by, remember, this is an x and this is a y. So we plug those 2 points in. I just took that equation, y is less than or equal to negative 2x plus 5, and you'll see that for x I plugged in the negative 1, and for y I plugged in my 2. And we want to simplify, so I do negative 2 times negative 1, that gives me 2, and then I combine those, I get 2 is less than or equal to 7. Well, 2 is indeed less than 7, so that is a true statement, which means we would say yes, negative 1, 2 is a solution. Okay, so that's what it means to be a solution. It's not necessarily on the line. It doesn't give us two pieces that are equal like we looked at last chapter, but it makes a true statement. That's the biggest, most important piece. It makes a true statement. Now to graph a linear inequality and the solution, we're going to start by graph the line in two variables. And when we draw that line, there's two options. We can draw a dotted line or a solid line. We do a dotted line if we use the symbols less than or the symbol greater than. We do a solid line if we have the symbol less than or equal to or greater than or equal to. So the biggest difference there, no equal to piece for a dotted line, equal to piece for a solid line. Okay, then we're going to choose a test point. So after we've graphed and drawn our line, either dotted or solid, we choose a test point for a possible solution. Now this is important. The test point cannot be on the line you just drew. The easiest test point is 0, 0. That one usually works pretty well for us. Unless it's on the line, then we have to choose a test point, or a different test point. Now here we're either going to make a true statement like we saw in that last example, or a false statement. If the test point is true, meaning the statement is true, we shade that side. So we're just going to draw and shade and color in everything on the same side of the line as that test point. If it's false, then we're just going to shade the other side, because then that has to be where all of our true statements are be. It always has to be one or the other side of that line. So an example of that, if I have my equation, that same one, or my inequality, that same one we started with before, and I can draw my 2 points. So I'm going to use this as in slope-intercept form. I've got a y-intercept of 5 then, so I'm going to put a point here at 5. And then my slope is negative 2 over 1. So I'm going to go down 2 and right 1, and I can do that a couple times. I could also go up 2 and left 1, don't forget. And I can draw that line. And then I'm going to, let's see here, draw a line that goes through all of those points. And you'll notice that I made my line solid, not dotted, because we have the or equals to piece there. So it should be solid, not dotted. Okay, next thing I'm going to do then is I need to choose a test point. So like I said, 0, 0 is a good test point. So I want to see, does 0, 0 give me a true statement? So I'm going to plug it in. 0 in for y, less than or equal to negative 2, 0 in for x, plus 5. And I can simplify. So the 0 is nice because everything times 0 is just 0, and we're going to have 0 plus 5, and then I can simplify that. I get 0 is less than or equal to 5. Well, 0 is indeed less than or equal to 5, which means that makes a true statement, which means this point is a solution. So we would want to shade everything on that side of the line. And in fact, I can even extend this line so that I cover the whole graph, and we could shade everything over here because all of these points are a solution. If I chose any one of these points, like this random point right here, and plugged it in, I would get a true statement. Okay, so that is it for this lesson, really. We're going to graph the linear inequality the same as we always have before. Just remember, it's a dotted line if we use less than or greater than, simply those two. It is a solid line if it has the or equals to piece, so less than or equal to, greater than or equal to. And then we choose a test point. 0, 0 is a great test point usually, as long as it's not on the line to shade or to test. And if we get a true statement, we shade that side. If we get a false statement, we shade the other side. All right, see you guys next time.